in Rayong province, it's called Wangjan Valley. Yeah. And at that area, we have some testing facility for the EV, and that is the biggest testing center for electric component. And when we talk about facility, I just would like to share this information. You might familiar with the component in the EV. It consists of the battery, of course, is the energy. So the battery provide energy to the inverter and then work together with the motor. And today, actually not just today, but the next week we will focus on these two parts. Yeah. Just only the motor cannot work, so we need to work with also with the inverter. So I hope after the class, at least everyone can know about the motor, how it works, and what kind of the motor is suitable for the EV. I don't expect you to design the motor after finish this class. Of course, it is for electrical engineering, not for mechanical engineering or automotive engineering. But at least you can select the proper motor for your design target, and at least you can know some kind of the motor and the fundamental how it works. And also the VCU, is an electronic part just to command some signal to the inverter and then to control the motor. For each component, as you see, we have some facility to test with this component. For example, for the battery, we have something like BMS HAL. Maybe we talk HAL later. It plays the important role nowadays when you talking about how to develop the electronic or embedded system in the automotive. Yeah. And for the HAL, we have three equipment: BMS, VCU, and motor controller HAL. And for the charger, we have something called charger analyzer, and we have the biggest motor test bed here available up to 380 kilowatt. That is the biggest one in this Southeast Asia at the moment. I can say that for the public service, we have the biggest one. So actually, if you work with some company and they want to test, they can come to one, and we can follow some international standard, UAN 85 for the net power and ISO 21782 for the testing procedure for electric powertrain. Yeah. And here are some pictures. If you have a chance, you can visit us as Rayong province. But today, just give some picture that we have. Here is the dyno test bed up to 380 kilowatt. Yeah, the biggest one. And we have the charger analyzer here. And for the HAL, we have the motor controller and the VCU. And each HAL will play as the simulator for the vehicle or for the motor. And for the BMS, we have this kind of the BMS HAL. This will play like the battery, because with the real battery we cannot change some function of the BMS. That is why we need to have something like this to give some certain condition, and then we can check the function of the BMS work well or not. Yeah, because for the battery, as you know, is the most expensive part in electric vehicle, and BMS, that is the one that can protect the battery. So if you have the good BMS, that means you can have the good battery. You can prolong the lifetime for the battery. If the battery BMS doesn't work well, function not good, so that it will destroy the battery. So that is the equipment we have, just some introduction. And at the moment, I arranged some EV motor training. Actually, not only the motor, we also have many workshops. But today, so we talk about the motor. That is why I pick up some motor training that available in this year. If you're interested, you can join us. We have the motor controller HAL here. We have the real motor controller from the car manufacturer to show how it works when you need to check some function of motor controller before you control the real motor. That is, it will arrange this week actually. Yeah. And we have the motor designer. If you are interested, we need to do some finite element software to design the motor, and it will show in this workshop. And the last one is about how to test the motor. Yeah, we have the small test bed here at Pathum Thani province, and then we also have the large test bed at PECI. And it is the 3 workshops available in this year. So, as I mentioned at the beginning, after this lecture, I don't expect you to design a motor, but at least you should know why electric motor is suitable for electric vehicle, why we don't use the ICE. Maybe we can compare about it, what the benefit, what the drawback. Not just only one solution can fit all, but we can select which one is suitable for your application. And as I mentioned, at least you should know about the type of the motor in the EV. Maybe I don't need to go in mathematics too much, but okay, we can not avoid some mathematics, but not too complicated. At least to know how to use, to calculate approximately some function, and each type of the motor, maybe you need to deal with something not the same, because the fundamental for each motor is not the same. And this is the question that I got very often, what the difference between PMSM and BLDC. I'm not sure have anyone in this group have worked with the motor before? No? Okay. So actually when I was a child, the first feeling I work with the motor is like a toy. We have the small car, and then we have the motor inside, and put the battery, and then just turn on and it's run. Yeah, it's no control or do something like that. But so that is the first feeling that I work with the motor. But okay, for the motor in the EV, it's not simple like that. So that is why this question, at least after this class, we should distinguish between PMSM and BLDC, because somebody said it's the same. There is something the same. There is look like similar or something like that. But actually, there are something different, and I hope you can know about this. What the difference between PMSM and BLDC.
What is PMSM and BLDC stand for?
Yeah. PMSM stands for permanent magnet synchronous motor. So I will show you some how it works. In the lecture, that is the stand for PMSM. For BLDC, the brushless DC motor. And you wondering why it's called the DC? Actually, it's not the DC, but the name is DC. Why is that? I will show in the lecture, and after this class, you can distinguish and you can talk with any people. It's not similar. Somebody said it's similar, but in theory, it's not similar. But okay, we can see what the difference. And the next one is also come out when you use the EV, when something wrong with the motor, or I don't know, in the garage, something, some damage. So how can we check if the motor is good or not? And that is the question for the manufacturer here, and also for the entrepreneur here in Thailand. Somebody want to fix the motor. It is possible to fix the motor in the EV. Maybe we will check it, and I will give some idea how to check the motor at the beginning or at the end. What we can get some information from the motor. And maybe I can give some overview about the situation in Thailand regarding about the development of electric motor for the EV. Actually, in Thailand, we have so many manufacturers. They are produce the motor for many applications like the fan, compressor, blower, pump. Actually, we are I'm not sure, maybe the second largest producer for the air conditioner, for the motor in air conditioner. It is possible if we move from this application to the EV, there are some barrier that we need to cross over or something like that. So maybe we talk about information of development of motor in Thailand. Yeah. And the content for the lecture, maybe not every slide available in your handout, and because some license or some license like that, then yeah, but I try. And another thing that the person who take this class can get some more information not only in the handout. And I start with the fundamental of electric vehicle. Maybe this part is not the big issue because you already learned with Dr. Aswin in the beginning of this class already, but just repeat very fast to show about why we need to use motor for the EV. Yeah? Not only the whole fundamental. Yeah? And then we start with our main topic, electric motor for the EV. Yeah? I will share some principle, how it works for each motor, how many types of the motor available in the world. So yeah, it's so many types of the motor nowadays, but just only some types that used in the electric vehicle at the moment. Yeah, and then about the type of the motor, and then finally we will show how to test the motor. Yeah, we need to inspect the motor, what the tool, what equipment we should have to test the motor. Yep. So first start with the fundamental of electric vehicle. Actually, I start with the structure of electric vehicle. It's not common one maybe, but more or less the most component here is available in the EV. But some car manufacturer, there are some topology or there are some thinking or procedure how to combine some part together. You might heard about 3-in-1, 4-in-1, 5-in-1, 8-in-1, or 11-in-1. Yeah, they try to use everything compact in one package. Yeah, but this one I just distributed. They have to show each component, and when the car company want to combine something together, just depend on them. But at least we know the basic principle, and this is the main component that we have. Of course, we have the high voltage battery here. Actually, is connected to the HV box, is the high voltage box. But some car manufacturer call power distribution unit, yeah, PDU, something like that. And in this one also connect to onboard charger because the battery needs to charge. And there are two ways to charge the battery, with the DC or with the AC. So for the DC you can charge direct to the high voltage battery, but for the AC you need this equipment onboard charger to convert from AC to DC, yeah? Because the battery is in DC. Yeah, that is why we need to have onboard charger here. And for the HV box, we connect to motor controller, to the motor, of course, to the wheel. Yeah? Because we want to drive this car, the motor will connect to the wheel. And for the HV box also connect to the air compressor. You might heard that for the EV, yeah, we use the energy from the battery. So we can use the air compressor connect direct to the high voltage battery to supply for the air compressor. It's not like the ICE car that you need to connect with the chain and then to produce some energy to supply for the compressor. But for EV, we use direct from the battery, the energy from the battery. And we also have DC-DC converter to supply auxiliary load. Yeah, it's something like the die charge in the ICE, just to convert from the high voltage to the 12 volt, for example, and then to supply auxiliary load. And it is the overview of the structure. And when we talk about the characteristic of the EV, what we want to have, actually the automotive designer, they want to decide that at the beginning they want to have the high torque, because the torque is mean you can accelerate. Yeah? If you don't have torque, you cannot accelerate. The acceleration is not good if the maximum torque at the beginning is very low. That is why we want to have the torque at the beginning, and at the end we want to have something like the constant power. The wider the better, yeah, because you can command to the very high speed, but you need something like the power is not, you need something like constant power here. If you have the wire that you can keep the longer, the higher speed, yeah, when you have the power at a certain value. But after this point, yeah, the torque will be decreased, yeah, but you cannot increase the torque and keep the power constant at the same time, yeah, because you know power equal to torque multiplied with omega or the mechanical speed. So if you have higher torque, that means and with the high speed, the power increase. If you want to keep power constant with the high speed, that means you need to reduce torque. Yeah. That is the simple mathematics. Yeah. And it is the ideal drive characteristic for the EV, constant power throughout the operational speed range. And when we compare between the ICE and the EM electric motor, and maybe you're familiar with this graph when you talk with the ICE, you have the torque here, the yellow one, and the blue one is the power, yeah, something like this, yeah. But when you compare with the EM you can have at the beginning with the maximum torque, and after that you can keep power constant for the wide area. That is why when we compare with this ideal characteristic, that is why the motor might be the good choice to drive electric vehicle, because you don't need to have the special gear for electric motor. The motor can control any speed, any torque by just control current or control the frequency. Yeah. So you don't need to concern about the gear, but for the ICE you need to have something like multiple gear, yeah, just to get this kind of the graph. Yeah. But for the EV you can get this graph by the characteristic already. So that is why they can use the single state gearbox, something like that. Yeah. But it's not, as I say, that it's not fit for all. Yeah. With some application, maybe single state is not enough. So like a racing car, maybe there are some special requirement. So or the truck or heavy load truck, maybe they need some special character. So that is why we need to design properly. But at least when you see this one, that is why the gear can be simple. Yeah. When the supplier in the automotive industry, they know about electric motor. They don't need to use the gear, complicated gear. I say that complicated gear anymore. That is why they are so concerned how can they survive in the future if electric vehicle doesn't need the gear anymore. Yeah, that is also the question. That is why some suppliers need to adapt themselves and then just to do another product that fit for the electric vehicle. Yeah. It is the compare between the IC and the EM. So just finish the fundamental. I think you already know about this, but there are a lot of lecture at the beginning, I think. So today, just cover our topic now is the electric motor for EV. So before we start to talking about electric motor in the EV, just know some definition of electrical drive. Yeah. As I mentioned, the motor standalone cannot work. So that is why they need some component to work together. So at this slide, as you can see, I don't use the word electric motor, but I use the word electrical machine. Yeah, just remember this word first. Yeah, because we will talk about it later. What the difference? I'm not sure everybody heard about machine before. Yeah, machine, there are some definition inside. But okay, let's start with the wording electrical machine. This is the component that connect to mechanical load. Yeah, that is direct connect. So before we can connect the energy source to electrical machine, we need some component. It's called inverter or converter. It depends on how to convert. If we convert AC to DC, we call the converter. If we convert DC to AC, we call the inverter. Yeah? And in this case, actually, we convert from the DC to AC. If electrical machine is the AC, that is why we need this component to convert the energy source from the DC to AC to supply here. Because if you connect DC source direct to electrical machine with the AC tie, it doesn't work. Yeah. At least if you seen about some picture of the motor, usually if they are three-phase is very popular at the moment. Everybody use three-phase machine. There are 3 terminals. But if you use energy source for the DC, usually there are 2, plus and minus. That is why you cannot connect plus minus direct to the 3 terminal of electrical machine. That is why you need to have this equipment or device to convert from DC to AC. And when they convert, they need controller. Yeah, because this one is just like the switching, just on and off. But how they can know when turn on, when turn off? This comes from control or the controller, and they need some sensor that feed from the electrical machine and from the load back to the controller, and controller can provide some switching signal to the converter, and at the same time they also send some sensor to calculate when to turn on, when to turn off. Yeah. And this is how it works. When we talk electrical drive, actually this consists of 3 components. Yeah. Consists of converter, machine, and control. If you are missing one part, it doesn't call electrical drive anymore. Yeah, you need to understand this one first. They need to work together. Yeah, this is one definition, and this is some drive system. The example in the EV. In this picture comes from Volkswagen. It's called 3-in-1 powertrain. So it consists of the one, it means the motor. The second one is the gearbox, and the third one is the inverter here. It's like a square box. Here is the inverter. Inverter will convert from the DC to AC to supply to the motor. Motor actually consists of 2 components, the stator and rotor. As you see, it's very simple when you compare with the engine. Engine maybe you're more familiar than me, but for the motor it's very simple. Have only the copper here, the steel here, and the rotor with the magnet. That is how it works for electric motor. Yeah, but you will know more how it works for each type of the motor. This one called the PMSM, the permanent magnet synchronous motor, because in the rotor we have the magnet inside. And this is one example from Volkswagen. It is from Audi. It's the street one also, but in different configuration maybe. There are some gears here, the stator here, rotor here, and the inverter here. And it is from the first generation maybe, but now they are developing another type of the motor. So let's come back to the word electrical machine. As I mentioned, when we talk about something in the car, we just know about the motor. But actually, it's the wording called machine because in the car, we also need to provide some mechanical energy. Sometimes we want to get some electrical energy. That is why actually in the car is the electrical machine, not the motor. Because when you heard about EV, the one benefit of the EV, you can get some energy back or regenerative braking, something like that. And we will see how it works. But That is also one benefit compared with the ICE. Because for the EV, when you want to use as the motor, that means you want to consume the energy from the battery, they work as the motor, they convert electrical energy to mechanical energy to drive the wheel. That is one way we call the motor mode. But in the same way, if you want to generate something back to the battery, that means we want to transform mechanical energy back to electrical energy to battery. That is the one benefit of the EV. It can generate energy back. For the ICE, you cannot generate the gasoline back. Yeah. But for the EV, you can generate energy back to the battery. That is another benefit of the EV. So that is why actually the device in the electric vehicle is called the machine actually, but we say motor maybe motor is more familiar for us, so that is why I will call the motor, not the machine anymore. Because we familiar with the motor, but just to let you know that they can work not only the motor, they can work as the generator. And when we want to work as a generator for EV, is very simple. You just change some control algorithm. You don't need to have some special gear. That is the one benefit of the EV. Yeah, because for the ICE car, you need when you want to go back, that means you have to use the reverse gear. But for the EV, you just change some control system, and then the car will go back. Yeah. So we will talk about later how it works. So yeah. So now I will use the motor, not the machine, because it's easier. So let's start with some fundamental of how the motor can turn or rotating. Yeah. Do you know how the motor can turn? Just put the electricity and it turn or something like that. Yeah. But actually behind the fundamental of how the motor can turn, they use two force production. Only two force production can turn the motor. It depends on the type of the motor. Some motor use only one force, some motor use both force. It depends on the type of the motor. That is why at the end of this lecture, at least you can know which motor use which force, and what is important. So let's talk about the first force. Is the Lorentz force. Just the meaning maybe. There's some name of some person. The Lorentz force is come from the force generated by conductor carrying electric current moving in magnetic field. Do you understand this sentence? Maybe you need to translate more. It's very simple explanation. We say that when you have the magnet, maybe draw some. For Lorentz force, actually, for example, we have the magnet. Yes, you have the flow here. And if we have the conductor, just stand in between this magnet, and then we put some current here. Current is high. So according to some fundamental rule of Fleming law, the left-hand rule, we call that the current, when we, for example, if we put current here, like put into the blackboard, and the current on the middle finger here, also here, and then we have the B. B is here with the magnetic from N to S, and it will generate the force. So that means from the Lorentz force, if you have the magnet, you have magnetic field from N to S, you have the conductor stand in between, and then you put the current into this conductor, it will generate force. That is called Lorentz force. Yeah. It's and some the equation is F equal to I multiply with L is the length of the conductor, and multiply with B. B is the magnetic field. Yeah. That is the first force that can make the motor rotating. Yeah. It's called Lorentz force. For the second one is the reluctant force. Reluctant force, for the definition, is the force generated by change in electromagnetic resistance. Magnetic resistance we call reluctance, yeah, where the magnetic field line pass through. So just remember this word, reluctance. This will play some important role for the current motor at the moment. For the Lorentz force, you don't need to put any current into the conductor. But actually it works like this. If you have some core, like the steel, and you can put I here, and you have core here. Usually when you put the current into the conductor, it will generate magnetic field. That is the principal one. And in this case, when we put the current to this coil, they try to generate some magnetic field here. And usually this will try to go to be closed loop. Yeah. Because usually they try to be closed loop. And when you have a gap here, so that means this is the force happen because of reluctant force. They try to the gap smaller. Yeah. It's like a magnet. If you play with the magnet, you have N and S, and when you push together, they try to put the gap to minimize the gap. It's similar, yeah, because this is called the reluctant force. You don't need to have something like the conductor with the current. Yeah. That is the definition of the reluctant force. So just to know about some fundamental principle, how it works. That is why we have two forces for the motor. So this is one interesting that actually I want everybody to know how it works when we talk about the operation in the motor. Usually we call that is a full quadrant operation. Yeah. Before we go that, as I mentioned at the beginning, electrical designer, electrical engineer need to work together with mechanical engineer. So that is why there are some connection between electrical and mechanical. So I want you to understand about what the connection first. We have some parameter. I will explain more. Okay, this is a four important parameter for electrical and mechanical. And when we distinguish this one, this is the electrical and it is mechanical. Are you familiar with the mechanical angular frequency? It is electrical angular frequency is the speed. It's a frequency, electrical frequency. So when we talking about the unit, you might know about RPS, revolution per second. This is the Hertz. This is the radian per second. It's also radian per second. What the connection between these four parameters? So when we want to have the frequency, we need to multiply with P. I will explain later what P is. When we want to have omega, we want to multiply with 2 pi. When we want to convert from electrical frequency to mechanical frequency, we need to multiply with 1 over P. And then when we want to transform mechanical angular frequency to the speed, we multiply with 1 over 2 pi. So what the P is? I think everybody know 2 pi. Yeah, is no question, but what the P? P is pole pair. What pole pair? Yeah, the next question. What pole pair? I think in ICE you don't have pole pair. Maybe you don't have pole pair. But for electrical machine, we have this working pole pair. And it's very important. Someone want to tune up the motor, they need to put the correct pole pair. Otherwise, your motor doesn't work. So, in the motor, and maybe I have some picture show later how to count the pole pair. But in theory or in principle, the pole is mean. As I mentioned, we need to work with electromagnet or permanent magnet. We have N, S is the magnet. If we have just only one N, one S, is one pole pair. If you have two magnets, S is a two pole pair. And pole pair you can have 1, 2, 3, 4, 20, 30, depends. Yeah, it depends on machine designer. Yeah, but maybe I give some number what the optimum pole pair that we use at the moment for the motor in the EV. Yeah. Okay, just understand the pole pair. This means just number of pole. Yeah, is a pole like permanent magnet pole. NS is one pole pair. Is when we call it a two pole. Yeah, this is a two pole. Two pole is equal to one pole pair. This is a four pole. Please be careful about pole and pole pair. Someone confusing or someone mix together. Some manufacturer request pole. Some manufacturer request pole pair. Yeah. And if you don't know, you just guess. Yeah, but maybe it's something wrong on the inverter. Okay, now you know about the pole pair. Already is the P. Yeah. And that means if we want to, this is usually we can measure or we can see by, in physical we can see this one, the speed. We can do some tachometer to measure the revolution per second. And this one actually we can have oscilloscope. I'm not sure in mechanical you have oscilloscope. You can use some signal from oscilloscope to calculate the F. Yeah. And maybe I have some small question to play around how to calculate this number. Yeah. And from this one, from this relation, so actually we can another definition I would like to say is the power. Yeah. Because power, I think you know, is for the mechanical engineering, they know about torque and speed can generate power. But for electric power, usually come from P equal to V multiplied with I. Yeah? V is the voltage, I is current. But for mechanical power, P equal to F T when we talk about the linear motion, but in this our motor usually it will rotate it, and that is will equal to T multiplied with omega. It is also the one relationship between electrical and mechanical. When you talk about electrical, we use the P equal to V multiplied with I. When we talk about mechanical power, and in this case we use P equal to torque multiplied with mechanical angular frequency. And this definition, when we will summarize how it works in this area, so we come up with this. You may remember about this diagram. This is the motor. It's connected to the load, and this connect to inverter. 1, 2, 3, and connect to battery. Plus, minus. This is the normal configuration, the battery, inverter, motor, and load. And for electric power, we multiply with I. Usually the battery will have voltage, positive. Usually the battery you cannot reverse the polarity of the battery. If battery plus here, it should be plus here. You cannot revert to minus. That is the simple one. That is why for the battery, the definition of the battery, when we consume the energy from the battery, that means the current will flow from battery to inverter. Current positive. It is the definition of positive power. Just remember this formula. So when we call in the motor mode is the V multiplied with I. Both are positive. And then energy from battery to motor. In another way around, when the motor breaks, that means the current will flow back from inverter to battery, I minus. In this case, as I mentioned, the battery still have positive because we cannot reverse the polarity of the battery. At this moment, this one we call mode 1. At the scenario 2, when we break, that means the motor will generate current back to the battery. We call generator mode. And in this case, P equal to V multiplied with minus I. So that means you have minus P. You need to have positive. Plus P, it is a minus P. At the second scenario, for the motor, something like this. For the generator mode, then we have the negative current here. At the same, for mechanical power, so we want to see the relationship between electrical power and mechanical power. In first case, when we want to have positive power of mechanical, for electrical, for mechanical. In the first case, if we have the torque positive and omega positive. That means in this case we have power positive. Power positive for mechanical. Power positive for electrical. You see? So that means in our definition, when the motor consumes energy from the battery, the current flow from battery to the motor and the mechanical, that means the torque positive and omega positive, you have positive power. That is we call motor mode. What do you think about mechanical power? There are another possibility to have positive torque. When you want to have positive torque, another possibility means you want to have torque minus omega minus. Yeah, because for the power is a torque multiplied with omega minus torque multiplied with minus omega. You also can get positive torque. So that means for the mechanical aspect, you can have two possibilities to work as the motor mode. The first case with positive torque, positive speed. The second case, negative torque, negative speed. At the same time, if you have positive torque but negative speed, you have power in negative. That means it's called generating mode. And negative torque, positive speed, you also get negative power. It's called generating mode. This is a way to summarize what the relation between electrical power and mechanical power. Yeah. For the mechanical, you have 4 possibilities. But for electrical power, you have only 2, motor or generator. But for mechanical, you have 4. That is why we call 4 for that operation. Yeah, 1, 2, 3, 4. And the simple question in a car, when we want to drive the car forward, which order it should work? Yes? 1, 2, 3, 4. 1. Okay. Correct. Because in the first order, that means we want to put the pedal and the car move forward. Because why the car move forward? Because we want to consume energy from the battery to the motor. That means if I would like to work at the motor mode. Motor mode is positive power. And when you see about what is the motor mode, you have 2 possibilities. This one or this one. But our definition, when we go forward, speed positive. Yeah, that is why we select in the first quadrant here. When we want to go reverse, what quadrant we work for? So that means we put the gear arm, we move reverse. Which quadrant? 1, 2, 3. Sorry, 2. Can you do 2 here or 2 here? 2 here. Anybody guess? 1, 2, 3, 4. 3. Okay. Why? Why 3? The motor mode. Oh, correct. Motor mode. Yeah, and then torque negative. Speed negative. That means speed negative is here in this way. And torque negative is here. That means in quadrant 3. So when we want to go reverse, so that means we just control this motor in quadrant 3. They can move reverse. And if I say about regenerative braking, so in the EV there are some special conditions. We brake and then we get energy back. Do you think which quadrant they work for? regenerative braking? 4. Why? Yes. Any explanation why it's 4? Can you explain why you think it's 4 for regenerative braking? Explain from equation or explain by your feeling? Anybody guess? For the 4, that means the speed still positive. Can you imagine when you drive a car, you go forward and you take a brake, the car still forward. That is why the speed still in positive. And when we see speed positive, you will come in this area. It's a generator mode. Yeah. And what is the water tool? The second one. We use it or not in the real car. You go back, take gear R, and then you brake. Maybe you use a little bit, but not too much. That is why usually we use only quarter one, but the third one and the fourth one. That is for the normal car. That is I summarize here. It's gear D in quarter one, the first quarter, gear R in the third quarter, and for the second and fourth in the brake. But here regenerative braking it works here, and this one just go reverse and brake. Yeah. And from this formula I have one small question about how to calculate some number. Maybe it's the simple mathematics. Yeah? You don't need to integrate or something like that. Just multiply, plus, minus, maybe divide. If you have one model, for example, just imagine you go to some shop and you want to buy some motor, what you expect to have? Usually you expect to have some data sheet of the motor, but sometimes data sheet cannot show you everything, or even worse, show something wrong. Yeah. Because based on my experience, some manufacturer come to me, bring the motor, bring data sheet. I do some testing, and we found that data sheet and the motor not the same one. So that is why we are engineers. We need to know how to check. And if we have some motor in the future, for example, if you have some, I think you can buy some second-hand electric motor in the EV now. It's very cheap. You can buy in some second-hand garage. But my point is, how do you know about the specification of the motor? Do you know usually the data sheet of the motor what they're talking about? Usually you want to know about the power. Yeah. Usually you want to know about the power, how many kilowatt. Yeah. You want to know the torque. What's the maximum torque can this motor generate? You want to know about the speed. What the maximum speed maybe in RPM. What do you want to know more? Usually when you want to control the motor, yeah, or you design the motor controller, there are some more parameters that you need to know. The one thing is the pole pair of the motor. And some parameters like resistance and inductance. It is 6 parameters that you need to know from your motor when you need to work with the motor. Otherwise you don't know about how to control the motor properly, or your motor is exactly what you want to have. So I will talk about how to calculate or estimate pole pair of the motor. Somebody said it's very easy. Yeah? If we have the motor and if we can disassembly and we take a look in the rotor. Usually the rotor something like the cylindrical turn like this, and we have the shaft here, maybe. Yeah. And then when we have the cutting, yeah, for example, maybe we can see something like this. What is it? It's the magnet, for example. If they are PMSM, yeah, it's the magnet. It's a PPM. If we can see PM like this, we can know how many pole pair we have. For example, when we have 1, 2, 3, 4, that means we have 4 pole. That means 2 pole pair. Yeah? Pole pair is a pole divided by 2. But in reality, it's not simple like this. Because when you buy the motor, you cannot see something like this. You need to know how to estimate it. So, and today I will show you how to estimate it. And maybe this will be some question in the exam. Maybe it's a simple mathematics. How to estimate the whole pair. The first solution, that is the easy way just to cut and see and count how many whole pair. That is the first solution. The second solution, actually for the industry, they have something like one place, and then they put on the rotor, they can see the magnet inside. It's like an X-ray, but not the real X-ray. It's like a one sheet, one paper sheet you put on the rotor, and then you can see what's the arrangement of the magnet, and you can count on it. That is the second solution. But if we don't have this kind of the equipment, or usually when you buy the motor, you don't want to disassembly, because if you disassembly, something wrong will happen. The motor will be broken, so it doesn't work anymore. You want to keep it as it is. So from electrical aspect, we can estimate the whole pair. When you have the motor,
ไม่มียูนิฟอร์ม
as I said, you have 3 terminals here. Motor is a 3-phase. We have 3 terminals here. And here you have oscilloscope. Oscilloscope here. You connect oscilloscope to this point. Do you know how oscilloscope works? Have you used it or not? Oscilloscope in the lab. You have oscilloscope. Or maybe you can borrow some from the electrical department, and there are some oscilloscope. Oscilloscope can measure the graph of the voltage and current. In this case, we want to measure the graph in terms of voltage. So we can measure the voltage. So the simple one is the motor has a shaft here. When you turn this shaft by using some pry mover or screwdriver or something like that can move this shaft. For the permanent magnet, okay, just this one, for this case, just PMSM motor. Just work for the PMSM motor or BLDC motor. Later I will explain what about this type of the motor, but just now, just remember, this method works only for the PMSM motor or BLDC motor, or say that they work only the motor with the magnet. Because for the PMSM and BLDC, they both use magnet. The principle of this kind of the motor, when you turn the motor by using some pry mover, you have the magnet in the rotor. This magnet will cut. This magnet will generate the magnetic flux. This magnetic flux will cut the conductor in the stator. It will be generate the voltage based on Faraday laws. Pareto law says that when you have the rate of change of flux, you have the voltage. That is why when we turn this motor, you can measure the voltage here. It's called back EMF because the EMF is an electromotive force. It's like the voltage. Back it means it comes from motor back to the terminal. It's called back EMF. Back EMF here. Yeah. So for when you have oscilloscope here, you can measure some graph like this. This part is motor. Some motor can be the sine, some motor maybe not the pure sine, but it looks like sine. Yeah, some good motor should be something like this. We want to have the back EMF more or less with the sinusoidal shape. That is the good one. If it's not the sine, maybe it's not the good one, you can compare about the quality of the motor by using this simple back EMF comparison. But at least for this one, when we turn the shaft, we measure the voltage here. We test the signal from oscilloscope, and we can see in the time. For this one, we have the it's a one period, one critical period. Yeah. So, based on this equation, F and N. This one is the simple formula is called F equal to F OP, or F equal to N multiplied with P. As I mentioned, P multiplied with N equal to F here, or N equal to F OP. Yeah. From this oscilloscope, when we have the time period here, that means we can calculate F, because F equal to 1 over T. Yeah. That means we have this parameter F by using oscilloscope. And if we know about the speed that we turn here in RPS, we have N, we have F, we have N, we have F, so that we can calculate P. That is a simple mathematics by using this measurement to calculate whole pair. Yeah. You don't need to disassembly the motor. Just keep it. Just connect to oscilloscope and find something to turn it. With you know the speed, and then you can calculate the pole of the motor. One question: if when the motor turn at question 1. For example, if we have speed at 6,000 RPM, and then we have the period lies 2.5 milliseconds. Can anyone calculate T? Can someone use ChatGPT to calculate T? Just be careful. Yeah? Last time I played with ChatGPT, they give some wrong answer. Just make sure that it's related to theory. So, just give you some minutes to calculate P, maybe. By using this measurement, you know that the speed now we run at 6,000, and then we measure period here 2.5 millisecond. So what is the whole number for this model? I'm not sure it's the correct one or not. Just help me to try to find the solution. Can anybody? Dr. Asmin give some extra point. You can answer the question. If you understand the principle of this kind of the relationship, so in the future when you see the model and you get some specification of the model, you can estimate or you can know that how it works. Yeah? And it is the basic way to calculate as engineering. 1, 2, 3. Sorry? Any crew? Sorry? One. No. Actually, the number of pole pair is one integer. Usually 1, 2, 3, 4, 5, 6, or 20. Yeah. If I remember correctly, there should be something correct here. Come to the right. Yeah, as I said, just put here to ChatGPT, they give some number here. 4. Okay, I heard something 4. Any more answer? 4. Confirm. Can you do right?
ก็เปลี่ยนเป็น RPM
Can you come to derive it? Yeah. Can you come to show how it's done? 4 is correct. Yeah, but just how you get 4. Don't say yes. I say 1, 2, 3, 4, 5, 6. Yeah. It's a simple, yeah, it's a divide, multiply, something like this. Okay? So, the 4 is correct one. First, we have this equation, yeah, M equal to F O P, and we want to have P. That means P is here, and F is here, and M is here. So, F is from 1 over T, 1 over 2.5 millisecond. N is a 6,000 divided by 60 because we want to use in RPS. Here in RPS, not RPM, but we give you RPM. Because usually for speed we talk about RPM. Some guys talk about RPS, but not common. Yeah. So for this one, it's a 100. Here, 1,000, yeah, is equal to 4. Yeah. Correct one. It's a simple. I think one. Yes. Okay. Yeah. So now you know about what the relationship between the electrical and mechanical. We have electrical power, mechanical power. We have mechanical speed, electrical speed. So there are some relationship by using this factor P. So after this class, you can know about what the relationship between electrical and mechanical. Okay. So, part 2. Okay. Oh, okay. You are little bit. So maybe just finish this slide and then we got to have a break. Okay, for this graph, what important thing about this graph? What is the transient and continuous? Usually when you buy the motor, the manufacturer wants to show that their motor is very powerful. That is why usually they will provide the number with the maximum value just to make feeling like you got the powerful motor. But when you are machine designer or you are design powertrain, just be careful because in the EV there are some tricks. When we see the spec of the motor in the EV, you will see like 200 kilowatt, 300, 400 kilowatt. Oh, it's very large, very powerful motor. But usually, it's the maximum power. What the maximum power means in the electric motor for the EV? It means it can run only some second, not a minute, sometime, some second, 2, 5, or 10 seconds. That's it. That is why just be careful. Some guy decide the powertrain and then pick up some power by seeing only the peak power. It's not tell you the whole story. Just be careful. We need to see more in detail what the meaning that shown in the data sheet. And usually they don't show us about continuous power. I don't know why. Maybe it's like they don't want to share to somebody about the continuous power. It's maybe 1/3 or maybe half of the maximum power. Usually, if you get the motor like 150 kilowatt, maybe the continuous power is only 70, 50 kilowatt, something like that. So just be careful about when you read the data sheet of the motor. And what is the continuous mean for the EV? If you see the motor in industry, continuous means you need to run 24 hours, 7 days, maybe. You need to run for a long time because you want to produce something, you don't want to interrupt it. So that means continuous power for motor in the industry means you need to run 24 hours. But for the EV, I don't think everybody drive the car 24 hours. Even you can drive 24 hours, your battery cannot support you to drive 24 hours. That is why for continuous power in the EV it means, according to the standard, you need to change the motor for 30 minutes. According to UNR 85, when you define the net power of the motor, that means you need to run this power for 30 minutes. So that is why when we talk about continuous power, we know that this motor can run at least 30 minutes without any temperature rising or over temperature. Yeah, that is the definition of continuous power for the motor in the EV. So just be careful about this one. And when I show some example of the data sheet that I got from some manufacturer here, the yellow one is the power, is power here. Yellow one is here. You see it's right up and the constant power here. And for the blue one is the top. For the dashed line is for maximum. And for the solid line is the continuous or the rated. You see what the difference. The maximum torque is almost but the continuous torque only 22 or something like that. The power also, the maximum power is around 30, more than 30 kilowatt. But for continuous power is only less than half, around 30. So that is why you need to see what the meaning here. Yeah. And then you can see here the rated and the maximum power. But we are not lucky. Usually the motor manufacturer does not provide us something like this. Yeah. Unfortunately. So, but for this motor is come from European country. They try to give more as much as possible. But in reality we don't get all data something like this. That is why we need to distinguish or we need to translate by ourselves. And this is the graph that I want to show when you want to decide the powertrain. If you have this graph from the motor manufacturer and then you map with your driving cycle, yeah, and you plot together, you see that the red one is the rated power, rated torque, the black one is the peak torque. You see, the most of driving cycle is located within the red area here. That means it can run for continuous at least 30 minutes, as I mentioned. It is the driving cycle from the USA, that's UDBS and HWFT. Highway fuel economy driving schedule. Yeah. So that means when you decide your powertrain, you want more or less to select the motor to cover the driving cycle here. That is the idea when you want to decide your powertrain, and you can select your motor properly. Yeah. At least you need to cover the whole range of this driving cycle. So maybe I stop at this point. After the break, we will start our topic with the type of the motor. Okay. Okay, 10 minutes break.
So come back again around 2:40. 2:40.